All right, class, I lost my little Vanna White helper here, so I've got a couple of things going on. We got a timer to keep this 10 minutes or less, and I'm going to be walking back and forth working the camera, and you'll just have to deal with it. Steel beams. Steel beams are probably the most most popular beam that you're going to find in your basements holding up floor systems. You can get a relatively short beam to span great distances, so they make for a good option. Now, beams need to be stabilized at the top. If we don't hold the top of the beam sturdy, what will happen is the beam has a tendency to roll. The code book makes it specific to talk about the steel beam with regards to this, because if you're framing on top of a wooden beam, put together a little wooden beam over here, if I'm going to frame on top of this, it's easy for me to get two toenails into the top of the beam, and therefore it's stabilized. If I want to frame into the side of it, well, I'm definitely going to stabilize the top because it can't roll because it has two pieces of wood into it. Steel beams is a bit different because if I were to put a couple of floor joists on top of this, I have no real way of fastening into the steel beam at this point, and therefore the steel beam could roll. So the most common fix and the easiest fix to do that is to physically take a 2x6 like this one and mechanically fasten it to the top of the beam. All right, so we're going to drill holes through and we're going to through bolt it, or we're going to use a powder actuated gun and we're actually going to drive nails through. You'll have to check with your municipality on whether they want to see it through bolted or if you can use a powder actuated gun. But we're going to mechanically fasten a 2x6 to the top. Now we've taken this steel beam and essentially made it a wood beam. And now I can toenail my floor joists on top. My floor joists are nailed on top. As long as it happens every 2 feet or less, then the beam, the top of the beam, will be considered stabilized. Now, if you don't want to put this on, for some reason you don't have the room, you screwed up your beam pockets, the beam's sitting too high, you can have your floor joists lap on top of the beam. And to stabilize the top from flopping around on you, you would take a piece of 2x2 lumber continuously and you would nail it to the bottom side of the joist, pushed up tight to the side of the beam. That would stabilize it. You can also frame into the side of the beam. You can actually cut and shape the floor joist to sit in the side of the beam. Now this isn't going to work because I have a 2x6 in my hand and this is a 6-inch beam. But if this were a 2x10, I could actually slip it into the side of the beam and cut a notch out of the top. So I would notch it out and then I would rest it in on the bottom flange, and the floor joist itself would actually back here would actually stick up from the beam, and on the other side it would do the same. It would stick up. All right, now ideally what they'd like to see is if it sticks up about 1.5 inches, and then on top of this beam we can put a 2x2 across. But if you look in your code book, and especially if you look in Appendix A, it's going to ask you that if you put a piece of 2x2 across, that everything stays about 3/8 of an inch above the top flange of the beam. And this is because these floor joists are going to shrink. Okay? And when they shrink, if you don't leave that 3/8 gap, what's going to happen is you're going to end up with a lump in your floor. So we'll put this up on the board. You want to frame into the side of the steel beam? First, let's draw ourselves a steel beam. Okay? And we're going to come into the side of the beam with our 2x10, and then the 2x10 or 2x8 is going to come up, and it's going to be cut like that. Now, at this point right here, you have the full depth of the floor joist, so you haven't reduced any thickness, so it still counts as a full 2x10. Then what they're going to say is they want to see a splice run across. This carries your plywood across the top of the beam, and your next 2x10 sits in here like that. All right, so underneath you have 3/8 to a 1/2 inch bump underneath, which is easy to get rid of with some strapping. And up above, you have this 2x2 that's fastened in and that carries your plywood, but we have to maintain right here, we have to maintain a 3/8 gap, right? And that 3/8 gap is when these floor joists shrink down, that our floor remains nice and flat and doesn't get a big hump in it. You can also, with steel beams, you can actually take the steel beam and you can pack out the side of the beam. I gotta get it around these nails here. You can take 2 pieces on each side of the beam, bolt through the center flange, and then put your joists on the side on joist hangers like you would as if it's a wooden beam. And again, if you're framing into the side of the beam, it's obviously going to be stabilized. This isn't done very often. But what's interesting is, as a renovator, if you know that this can be done, because here's an opportunity to get a relatively short beam to carry a large weight and still keep all of your ceilings relatively flush. Now, steel beams. This beam right here, this exact one, is called a W150-22. So you're going to eventually look up in your Ontario Building Code, Table 923.3.4, steel beams supporting floors in dwelling units. And that's going to be on page 146. You're going to see this beam. W, like I said before, stands for wide flange, because it has a wide upper and wide lower flange. 150 is how tall it is. It's 6 inches tall. All right, soft conversion there. And over here we have 22. 22 tells us how many kilograms per meter, and it's 22 kilograms per meter. So this tells us a couple things about the beam. One, it's a wide flange. All of the steel beams that you're going to run across in the building code are going to be a W, or wide flange. In the building code, we're going to have 150, 200, 210, and 310. Let me double check. 150, 200, 250, and 310 millimeter tall beams. 22, why would they tell you how much it weighs per meter? Well, the 22 is going to be related to how much steel they actually put in the steel beam. Okay, so this guy here, if you look at it, has about a 5/16 flange and a 5/16 inch thick inner web. All right, and it's going to weigh 22 kilograms per meter. Now, if you wanted to get imperial on this, 22 kilograms, there's 2.2 pounds per kilogram. So multiply 22 kilograms by 2.2, that will give you the weight per meter. If you want to figure out how much it weighs per foot, divide that number by 3.281, because there's 3.281 feet in a meter, and you'll know how much this beam weighs per linear foot. Right now the code book's going to give it to you like this. If we had a beam that weighed more, if we had a 200, and let's say that it weighed 24 kilograms per meter, you can make an idea or an educated guess on how thick the flange and the web is. Now, with beams, like all beams, a 4-ply 2x8 beam or a 3-ply 2x10 beam, a 2x10 3-ply beam is going to outperform a 4-ply 2x8 beam, because it's taller. And we've said this a lot of times in theory class, that if we can get a taller framing member, it's going to perform better. And what we mean by performance is how much bounce and vibration the floor has. The same thing is to be said with a steel beam. You can get a really heavy 8-inch tall beam that will do a span, but if you can afford the headroom, you'd be better off to get a much taller I-beam with a skinnier flange and web. It will always outperform it. Okay, so again, if we're looking in at our chart on page 146 of our building code, We have a W200, which is an 8-inch tall beam that's 27 kilograms per meter, 31 kilograms per meter, all right? And then we can come down to a W250 that is 39 kilograms per meter. So this tells you roughly how tall the beam, not roughly, tells you it's a wide flange beam, its height, and its weight per meter. Now, on a side note, knowing the weight per meter is important. If you're going to put in a 15-foot long beam, and you know that it weighs 22 kilograms per meter, and you work that back into feet, this is going to help you figure out whether or not you need 1 person, 2 people, or 10 people on site to muscle this thing in. When we come back, we're going to start looking at the span charts for all the different types of beams.